Let's do question 6 now. A student plans a series of chemical tests to confirm the identities of the 4 organic liquids. So you got J, liquid K, liquid M, and liquid L. So if you look at it, you need to look at this sort of organic structures. So you can see here is it looks like it's a ketone in the alkene. Here looks like a carboxylic acid and alcohol. Here you can see a carboxylic acid and alcohol there. So that's secondary alcohol. And that one looks like aldehyde to me. So this is a student's method. The separate test tubes contain samples of each liquid. Add potassium dichromate 6 solution and warm gently. Add filling solution and cool in ice water. Add sodium hydrogen carbonate, solution, and test any gas produced with a lightly splint. Add bromine water and shake at room temperature. Identify the missing reagent in test 1. So test 1 here, add potassium dichromate solution and warm gently. So that's oxidation reaction, and you need H2SO4 because it's in acidic conditions. Okay. 6.2. In addition of missing reagent test 1, there's a mistake in the method for 2 other tests. So state 2 mistakes. Suggest how each of these mistakes should be correct. So mistake 1, cool in ice water in test 2. So that's, you don't cool in ice water because in test 2 you have add filling solution and cool in ice water. What you have to do is warm in water bath. So in the water bath and it's in warm water. Mistake 2, gas is tested in lightly splint in test tube 3. Bubble into lime water is the one because it's not hydrogen gas, it's actually CO2 gas being released. So you need to keep going here and have a look at what they say here. The missing reagent is added and mistakes are corrected. Identify the liquids J, K, L, and M that would react in each test. State the expected observation for each reaction. So liquids that react test 1 is J and M. Okay, so J and M, which is that and that. All right. So J and M, which is orange solution, goes green. Okay. Liquids that react test tube 2, you got M, which is your aldehyde. Here you got your carboxylic acid and alcohol. Okay, and you have your aldehyde too. So liquids that react test with 2, which is M, aldehyde. That is a test for aldehydes when you are filling reagent, filling solution. In the test tube, blue solution gives a brick red precipitate. Okay. Liquids that react test tube 3, so J and L, which is our acid present. So observation is colorless gas that turns lime water cloudy because it is an acid present. Therefore, you put sodium hydrogen carbonate to it. So you have bubbles of gas, CO2 gas coming out. Liquids that react in test 4, K. So K is this one here. All right. So test 4K. So this is a ketone and bromine. Add bromine, double bond here. Okay. Add bromine water and shake room temperature. So you'll react with that. Okay. And it will give you orange solution goes colorless. 6.4. Figure 10 shows the apparatus that is used to separate the mixture of liquids K and M using fractional distillation. Suggest labels that should be added position S, T, U in figure 10. Explain why fractional distillation is preferred to simple distillation to separate liquids K and M. So liquid K is you have got ketone and you have got alkene. And this is liquid K and M you have got an aldehyde. So you're looking at aldehyde and ketone, isn't it? Explain why fractional distillation preferred. So you look at this first, you have to label S here is a fractional column. Okay. T is water, water goes out here, water goes in here. And liquid K and M would have similar boiling points because you're looking at aldehydes and ketones. They have quite similar boiling points in here. So K and M. Okay. Let's do question 7. A gas syringe that does not have any graduations It's calibrated using known mass of propanol, boiling point 56.2 degrees. The seal gas syringe contains 0.146 grams of propanol. You got MR of 58, at temperature 95 and pressure 103, at 95 degrees centigrade and Celsius, and temperature 103 kPa. Calculate the volume in centimeters cube of propanol gas syringe. First of all, you work out moles of propanol. So you take your mass over molar mass, you work out the moles. The temperature is 95. To see that, you've got to change for Kelvin. Pressure is 103, you multiply by 1000 to becomes a PA, not a kPa. Use a formula PV equals nRT, V equals nRT divided by P. You plug in the values in there, and you should get the answer in meter cube. So you multiply by 1 times 6, and it gives you in centimeters cube. So the answer is 75. The gas syringe is then cooled at 75 degrees to 75 degrees without change the pressure. Calculate the decrease in volume. If you are unable to calculate the volume in question 7.1, you should use the volume of 89 centimeters. So volume is 348 divided by 368 times 75 gives you 71 centimeters cube. So then you have 75 minus 71 gives 4 centimeters decrease. Basically, it's the ratio, you know. If I got 368 to 75 centimeters, how much is in 348? And then you take away from the other one, so you get the answer as 4 centimeters decrease in volume. 7.3, a total uncertainty using the balance to measure the mass of propanol in question 7.1 is plus minus 0.001 gram. Calculate the uncertainty of this causes in the volume in centimeters cube of propanol. Calculate question 7.1. So basically, if you're unable to calculate the volume question 7.1, you should use the volume 89. This is not the correct answer. So you have got 0.01 divided by the mass, which is 0.146 times 100 gives you the uncertainty of 0.685. The volume uncertainty is 0.685 divided by 100, okay, times 75, which gives you 0.5 centimeters. So uncertainty is 0.5 centimeters, okay? 7.5, at 600 sample propanol mixed with 2,800 centimeters of oxygen, a container at 60 degrees at 100 kPa. The mixture is ignited. When the reaction is complete, the remaining mixture of gases is cooled at 6 degrees at 100 kPa. So calculate the total volume remaining gas. Okay, so you got 600 started, you got 2,800 oxygen there, and then you say the ratio is 1 to 3, so it's got 1,800 there. So if you look at the ratio is 1 to 4 here, so 6 times 4 is 24, that leaves you 400 left over here. So if you have 1,800 plus 400, it gives you 2,200 centimeters cube. So you just have to add that at the end because it's still there, the gas left over.